refresh the scene. Okay. So there's our data from the sensor. It doesn't have a clear line of the sky, so that's why. You see, if I put my hand above it, most of the dots like go near the origin. And then I open my hand back to the ceiling. So I want to preface this video by saying that a self-navigating robot is something that I've always been working on. Like, in theory, it's easy, you know. I want something that's beyond like a bump sensor. Something that like develops a map, you know, actual SLAM that's able to estimate like its position using an accelerometer, that kind of thing. But you can see that I've been working on this to some extent, whether it's this like single point robot that's, I called it twerk LiDAR, but you know, it was like wiggling the beam around to scan the environment. That process was really slow because it used, you know, 5 slices, and the time of flight sensor had like a 22 millisecond sampling rate. So it's also really inefficient because of the 12 servos moving together. And you can see that I've made like a newer version where it's like a pan tilt system on this wheeled robot. And I mean, all the hardware is there. I just never finished the software, but I saw this 8x8 grid sensor and I was like, whoa, you know, that's what I want, because, you know, really I want LiDAR, but those Velodyne things are pretty expensive and huge. Alright, so supposedly I'm working on a little self-navigating vehicle using these little motors here. That goes on the wheel like this, but I gotta actually mount it. Anyway, the focus of this video is to try out these 8x8 grid sensors. Pretty cool. Very small. I'll be using a Pico. Never used one before, so that'll be interesting. I try not to permanently solder reusable boards like this, so I'll solder on some mail headers and then I'll have a socket onto the PCB. Or it's a solderable prototype board. Alright, so I've got the Pico on a breadboard. I've got the sensor. I actually noticed it has this like little film on there that I gotta remove. I think it looks like it's supposed to come off. But yeah, I'm gonna look up how to interface this and then the library to use, and then I want to get you don't connect it like that. I'll stick it over here and then take the wires and connect them. But you gotta power it and all that. I'm gonna get these measurements, and then depending on how far I get, I'll probably throw it on Three.js so I can have a 3D thing in the browser to look at. I want to point out that I like literally don't know what I'm doing. Like I'm looking up, how do I connect this to that? You know, so I think this is all you need. It's like a standard 4-wire serial deal, or I2C, power, ground, SDA and SCL, the clock, serial data. And I just looked up pinout like that, and the pinout of the Pi Pico. So now I gotta find some code to program this and try it out. The thing I want to find out is like how wide and granular is it? Because and actually I was looking at this little tutorial here, and they have a single one mounted on here. They got a little car going around, which is like literally what I'm trying to build too. But it's interesting. It looks like it's actually trying to follow it. So maybe it is able to see the depth, like, oh, that side is deeper, this side is shallower, so I'm gonna go turn right kind of thing. So this is pretty cool. I'm trying to stick with VS Code or like Arduino, something like that. Initially I was gonna like do C++, but honestly I'm just gonna stick with Python. Like I don't wanna add more friction to this project. Personal friction. Like Python is easier to me than C++, so this is pretty dope. New micropython project and some other ones. Alright, so far I am failing. I think I understand like what's happening. When the Pi is brand new, Pi Pico has nothing on it. So when you plug it in, it's just like a mass storage device. And it was saying you have to flash code on it to get it to pop up as COM, and then you can actually run your code, like program it. Right now all of them are grayed out over here. Alright, so I still don't really know what I'm doing, but the docs say use Zadig. This was just pre-selected, so I'm like, alright, I'm gonna install it, see what happens. Alright, cool. Got something. After I installed it, I unplugged the Pico and I plugged it back in. Now to flash the blink. Baby's first blink program on the Pico. This came with the extension. Once I figure out how to program it though, then we can start designing our own setup, which will drive the motors, the IMU, and the sensors. It's gonna be 2 of them. This is gonna feed to a bigger project. It's like a robotic arm with a camera head, but that's way in the future. I'm still like tinkering on this on my spare. Alright, so it just asked me to flash the firmware, and it did it. Connected. Ooh, look at this. Cool. Well, I don't know what happened, but I killed VS Code and restarted it, and now it is connected. Hooray! Cool. So I clicked the file and I just hit run down here. Nice. Pretty cool, pretty cool. And it's blinking. Oh my god. It's like so stupid. Back to the basics, because I flashed this thing, ESP IDF. It's like, how does Pico work? Alright, this is cool. I'm glad, because like VS Code is my main editor. Got a license of Monokai Pro Spectrum, like I got it all kitted out. Alright, so this is great. We're able to program it. The next thing to do is find sample code to pull values out of here. The other thing I need to figure out is how to structure things. I think it works the same where it's like you got a main file, you got modules, you import them, it'll all flash together. So that's how I'll structure the code. You know, one file to access the IMU, one file for the sensor, one file for navigation, that kind of thing. And then main will just be a main loop. We got a ways to go. We got the motor driver too, but I flashed that a while back and got it working. Alright, so I'm looking for a library. This one came up. That looks pretty sick right there. MicroPython, I2C, time of flight instance. And there's probably methods to get the value. Get ranging data. Nice. Keep looking around though before I make the commitment. So it's interesting, I have like a repo, and this project is inside the repo. You have to open VS Code like at the MicroPython project level for the extension to recognize that it's in that environment. And then like after you open the VS Code, you plug in the Pico afterwards for it to be connected. Anyway, right now I'm trying to figure out how to import that module, the library. I don't know if I can just like pip install it, or do I have to install it in the extension somehow? So I'm trying to figure that out. Man, I still like don't really know what I'm doing, but here it's doing something. Source micropico. So I cloned this repo and I'm reading through the installation. It says you have a lib folder. Then you move the contents of this folder in there. So I did that. I got lib. I put the folder in there. And then I was trying to do this MP remote stuff, but I think VS Code is connected to it, so I can't control it manually. So then down here, you know, it says Pico connected, and there's all commands. And then there's the upload project to Pico. So I guess it'll work. Still trying to run the basic connection demo. This thing I don't understand, like from machine. What is machine? I don't know. Alright, cool. So it looks like once you do that upload thing, then the code will run. And now I just gotta match the pins. Alright, so I'm currently trying to figure out why this file is missing. The config bin. I think it is missing. So I'm in the REPL importer OS, listing the directory that's uploaded on the Pico, and it's not in here. I wonder why. Maybe it's too big. So I uploaded it manually, like right click upload, but it doesn't follow the path, so it's not in the library folder. So I have to figure out how to move that or delete it. Alright, cool. I used OS rename. That moved it. Pretty sick. So I'm currently dealing with this problem. Timeout. I thought it might be because it's not getting enough power, even though it says it can supply like 300 milliamps on the 3.3 volt pin, so I connected it external power. I didn't do anything. There's this issue. This guy's talking about adding this. He's got the same error, that's why I found it. He had this timeout. I tried that. it doesn't error, but the loop doesn't run either. So it's like, not sure. So I soldered another one just in case, and same result. I ran the I2C scan, and it does spit it out, like 41. So there's something with this library. Maybe it's the frequency. I don't know, I gotta try. Alright, so I don't know. I did that timeout and it did actually work. One thing is, I did actually upload the files versus just running them. I don't know. I thought they were like the same, but anyway, at least this is good. I just gotta figure out what this means. Maybe XXX is infinity? There's values now, like that. So that's the grid right there. This is only 4x4, so I need the 8x8. Holy crap, look at that. 8x8. I have the power. Nice. That's good. That's good. That's real good. That's interesting. The grid is like the gap between the columns. I just guessed, but it made sense. Yeah, so this is cool. The units are in millimeters, which I can only think in like inches, so I don't know, 6 centimeters, I guess. I gotta actually like do testing on this, but this is cool. Interface with it using Pico and micropython. So, and it's just that. So, thank goodness. So now that we've got data, I have to send it to a website through a WebSocket, and then the data is plotted in 3D using Three.js. So I'm gonna do that real quick. Those are things I've done before, so I just gotta piece it together. One thing to get down is the get down, know that song. The field of view angle, so it says 45 degrees. I think it's 45, so in SketchUp I can plot that for my own reference, but in Three.js the what are they called? Polygons? It's they're planes, 4 points, 4 vertices plotted in 3D. So those planes are all connected. It's like a mesh. You plot this grid, which is deformed based on what it hits. I want to do is show like my fingers going down towards the sensor, and it shows the deformity. But then the car eventually will have 2 of those sensors. They're like intersecting, so they kind of check each other, and then the car uses that to navigate. Alright, so I've been making progress. I've been poking around on how to do stuff, and this Hackster post here is pretty helpful. When I was Googling around, it said like, use microdot, and I was like, I don't really want to do that, but it's like, it's not that bad. So I brought in the files, the source folder, into the live folder. Then I looked up how to connect to the Wi-Fi, which the Hackster shows that too. So I've got I'm using a env file, so I filled that out with my Wi-Fi credentials. Got a little basic file line reader to pull those values, and then it feeds it into the connection, and then the microdot server. I still have to modify this code, but it pulls that module in, connects to Wi-Fi, and then I set the IP, the resulting local IP, that's the 192 address, for the host to run, or as host. So when I actually run that, it'll connect to the local, or to my Wi-Fi. It's got an IP 118 and then port 5000. So I go in the, well, I've loaded it before, but it's right here. This is a Pico web page, which I'm not really trying to use that, but it's showing that it's working. Like, there's the web page right there, Pico. But the main thing I'm after is this socket right here, WebSocket. The Three.js will just be a website that's running anywhere, any computer that's connected to the Wi-Fi, and then it'll find this socket and pull the data in from the sensor, which I still don't have that connected. What I'll probably do is pull the sensor code into the server, and then this like while loop here will just read from the sensor and send it to the client that's connected. So the next thing will be to get that working, where get a basic website. It's not a website, it's a web page with JavaScript on it. It'll connect to this WebSocket. This is not the socket, but there will be a socket, and it'll pull the live data from the sensor. And then from that point on, it's just plotting a 8x8 grid of data, which will be the mesh. Alright, cool. So we got the socket working. This is just a basic 1 second delay respond. The client is pinging every 3 seconds too. So yeah, I'll just connect the data from the sensor now, and then we should start seeing it come in over here. This is just a basic web page here, which you can see right here. Got a basic web page, imports socket.js. Socket.js is just this right here, connecting to the Pico's IP with the port, and then the custom endpoint. And then here's the ping messages coming in here. Alright, so made pretty good progress here. I refactored the sensor code so it's like a class. You can easily like instantiate it and have an instance. And then I realized it was just dumping like 64 values in an array, and then the for loop was visually formatting for the printing. So those values are being stored in a property scan values array. And then on server, which this is just temporary until I come up with the actual structure. Once I've got like the IMU code and the motor driver code written too, I'll put it all together. But and then the navigation algorithm. But so we've got the server file, which brings in the time of flight sensor. It runs it in a thread, the sampling loop. So this like while true loop here is running in a thread, so it doesn't block the rest of this code. And then this web server runs, and the socket is running, and it's serving the scan values every 100 milliseconds. It can go even faster, but I think it's way too fast. So then I connect on here. You can see all the values coming in. So this is what Three.js will plot over here. I just got to pull some old code I've written for my project. Yeah, Twerk LiDAR robot has the mesh plotter in Three.js. So that'll be the next step, and then that'll be it for this video. Alright, so I brought in the code from my old project, which a lot of this has to get removed. It's more about getting the Three.js environment where you can actually plot things. All the dependencies are defined, like a bunch of stuff in here, like orbit control, GTFL loader. I don't think I need that, but GLTF. That's like if you want to import a CAD model, like GLDB file, it'll import it. That's pretty cool. I used that before for the robot to make like a making a little simulator. But yeah, convex hull, convex geometry, stuff like that. That's not code I wrote. That comes with Three.js. I just got to bring all that stuff in, and then there's some utility functions like degrees to radians, that kind of thing. Getting specific axes. It's been a minute since I worked on this, so I gotta refamiliarize myself, but it should be straightforward. You just gotta plot a plane in 3D space, which is 4 vertices connected together, and then repeat that 64 times, and then you'll have your mesh, and then it'll just get replotted every time new data comes in from the socket. Alright, so I'm at my big monitor now. So going off of this 45 degrees field of view. Here's like a representation of that in SketchUp. So I believe we've got this 45-degree square field of view, and the 64 samples are divided from this area. So I've got all those values like in an array. You see here there's like 2 rows of 8, and I have to rebuild this thing based on those depth values. So I'm finding like 2 squares that are connected, or not 2 squares, a square, like 4 points that are next to each other, and making a plane out of that. But in order to do that in 3D, each point has to have 3 vertices, or 3 coordinates per vertice, like X, Y, Z. And you see where my thumb is, like the distance value is the very end where that Y is, the very end of that arrow. So you have to split the thing into parts using like sine, cosine. And then that's how you determine the 3 coordinates that represent the like Cartesian position in 3D space. So yeah, having something like SketchUp just helps. So I'll literally just sit here and divide this like this over and over until I've got the 64 positions. And I'm like cheating, but I need to get these points. This isn't like the actual points in 3D space. I'm getting the angles of each, because you need the angles to get the points. So yeah, that's what I'm gonna do, and then I'll be able to plot it here, because I've got a function to plot a plane with 4 points, or actually it's 3, but you do 4 of them. There's the 64 divisions. This is what I'm trying to recreate in Three.js. If you're like good at math, you could do this without even a visual aspect, but I'm a visual person and not good at math, so having something like a 3D model helps. So one thing I thought about is I don't know which direction the scanning starts, and Google said like bottom left to top right. So I don't know if that's like that kind of thing. I'm still looking that up, but in Google Images I saw this, which is a good point. They're considering the center point of the square, which makes more sense than like going off of the corners. I mean, I don't think it'd make a huge difference, but that's good to go for like the middle. Alright, so here's this. So yeah, I see what it's saying, like, it starts here, goes across like that. So that's good to know. Alright, so I've been thinking about this more, and actually it's not that bad. Like, you've got 45 degrees, and you think of it like an arc. You divide it into 4, so like each step is, 22.5 divided by 4. So it's like when you start at the bottom over here, it's like I don't know, it's the highest angle, and you go to the middle, it's like the lowest or 0 angle in that axis. So I'll just be able to write like a lookup table, which will match the value, the sensor value, like row. I might like sort them backwards because they start at the bottom, but they're written at the top. Like if you think of an array, arrays are pushed on. So I'll probably flip that so it matches this, and then I'll have a lookup that matches each angle of the point, and then the trig will come in and get the 3 values, and then I should be able to plot the mesh. This is where my brain sucks. Like, I know what I want to do, but I like stumble. But I get that I'm looking at this over here, so I want the first one over here, right? This one. So that is 4 times, well, it's the 22.5 value. So it's whatever the division is. But it's maximum. The coordinates are x, y, and z. That's the coordinate system I like. Z is like up. I used to do x, y, and then z is depth, but if you think of a 3D printer, up and down is z. I think that's how I have this configured, the Three.js axes. But anyway, yeah, so this one here is 4 by 4. Which really, that's how you do it. You write a function that looks up the angles based on the division. It's like this one is 3,3. Actually, no, this one is 3,3. Yeah, okay, I'll write a basic function that'll do that. And then I can just step over. Actually, I wonder if I could factor it into the loop that's running over these values. I'm gonna look into that. Alright, so I do want to get this done today. I'm gonna be a dumbass and just do it manually. At least I can flip the values since it's symmetrical. So I'll just individually map these and then literally use the protractor in the SketchUp tool to get these angles. I'm sorry. I could figure this out if I had time to work it out, but I want to just get this done because I have to make this video too. And yeah, we're still like literally right here. Angle map. This is the trig part too, like so top view you've got the X angle here. Side view, you've got the Y angle right there. Actually, it's Z angle. And then the other value is just distance, but you can get that out. Alright, so these should be the angles. I only did one corner, but it's like mirrored, So, you look at this 64 grid cone thing here. Take the top right corner, that's over here. Then you draw the lines to the middle of these squares, and then I individually went and grabbed the angles per like rise over run kind of deal, or component cosine sine. And then I plotted those here and they mirror, so negative on the left side because you're going left, positive on the right side, and then positive going up, negative going down for the next value. And this technically is a XZ coordinate system, like angle, but I'll make the math recognize it to get the values. But yeah, so now I need to write a function where I've got a util thing I wrote from the Twerk LiDAR robot, or is it? This is where you say like get y coordinate, get x coordinate, does degrees to radians, that kind of thing, and then does the actual math, like math sine, math cosine. And then when I prove it that it actually works, I'll scan like a wall and I should get a perfect like plane in Three.js. And then when I put a shape, I'll deform it as expected, like deform it from the top, deform it from the bottom, deform it from the right, deform it from the left, kind of thing. That's how I'll know like I've accounted for all the grid or depth samples. So to start with, I'm gonna just plot the points in space versus like a mesh. That way I can be sure that it's working right. And then, I don't know. What I was thinking is I would link the meshes together. It's really just a visual thing. I mean, points would show the depth reaction, but it looks cool. I'm still sitting here dealing with this like flipping of numbers. It's funny, you could like physically just flip the sensor, but that changes things too, so yeah. Just trying to work it out in my head how this thing will work. Because like I mentioned, it starts from the bottom left, goes left to right, like it goes like that. But then arrays are stored like, you know, the data is recorded like left to right in an array, so that doesn't match like that pattern. You have to flip them. Man, this is like confusing, but I did get it. I'm like a visual person, so the first thing it measures is that one, right? 1634. So then you go over here to the output, and the first thing it measures is down here, 1634. This is regarding that grid where, hold on, where is it? This right here, where like the first measurement is this one. So that's what I did, is just transform this data to match that. So this is like the back view, like what the sensor sees. First measurement is over here. Kind of confusing, but yeah. So then I just gotta plug the angles in, you know, from SketchUp, like these angles. Get the vertice coordinates, the three numbers, and then plot those points in Three.js over here. And I'm blanking bad. There's three like points. In this code here, it says get z coordinate. I'm trying to remember how to do that. Tilt angle? Sweep, sweep, tilt. I mean, and I got the distance. I guess, yeah. I have both those values. Man. My dumb brain. Alright, so I've got something, but I don't know if it's right. So I think at this point I'm going to use this and bridge them together. Then I'll point the sensor at a wall and see if I get a plane. Because right here it looks like there's a grouping, clustering. So maybe it's correct, but I gotta verify it. That's pretty dope though, look at that. Yeah. I'm not gonna do the mesh today because it's gonna take time. And I also need to verify that this is working correctly, but on the surface it looks like it's working correctly. Alright, let me do a quick demo here. Refresh the page. Got our sensor over there. Go to the server, restart it. starts streaming the sensor data. Refresh the scene. Okay. So there's our data from the sensor. It doesn't have a clear line of the sky, so that's why. You see, if I put my hand above it, most of the dots like go near the origin. Alright, I'm going to do a quick code overview what we've got so far. This is just a background in this project. I wanted to make like another tail dragger thing but smaller, and he uses like the Pi Pico. It's got a display, and he uses those two sensors, which I later was thinking they would look like ears. This looks like freaking Ratchet and Clank, but yeah. I was thinking, you know, this is going to be the display, so you could animate that, have like little eyes. I was thinking like a single big eye, and then like two lights or something. That doesn't really matter, but there's your geared motors, tail dragger design. But yeah, that's the idea for this project. So I'll just go over the code for the time of flight sensor and the WebSocket transmitting to Three.js, which a lot of this is just sourced from tutorials or whatever, so it's not like I really made anything new, I just put it together. So the entry point right now is server, which in this video you'll see I start this up, and this is the socket. So when this runs, this is like main right now until I finish the rest of the project. So you first got to connect to Wi-Fi, so that's imported from here. You put in the SSID and pass in an environment file, pull it in here, and then start your sensor instance, which is this right here. Put in your I2C pins. I don't use the LPN pin, so that's not connected. This is, you need this right here, this timeout 500,000. For some reason, it just won't work, and there was a GitHub issue. This guy mentioned that. So, got that. Sensor started. Then it's just storing the values it's sampling to itself right here. And then since this instance is right here, then the socket can pull the values out of it right here, time of flight scan values, and then it's sending it to the web client that's connected to it. And we'll go to that real quick. This is not where this code will be in the future. That's just the current state of the project. So got your index right here, which most of it is just Three.js dependencies. You got a canvas, the plot, and then socket connection. The socket's very basic. It connects to that IP from the Pi Pico. This is potentially a dynamic variable, but right now it seems fixed. But yeah, this is the WebSocket endpoint. Connect to it. It starts receiving the data. You say plot sensor data right here. So when you look at that, most of this is just setting up the scene, camera, and whatnot. A lot of these are not used right now. These are from another project, but this is the thing right here, plot sensor data. I talk about this in the video, but the way the scanning works, it starts at the bottom left, goes to the top right, but the data is stored in an array like this, where it's like first value 1, and subsequent values is appended. So if you were to put that in a row column setup, it doesn't match. So you have to like flip them around and match them, which I took a bit to get that working. These angles right here are, I showed in the video, this SketchUp, they're the segments of the 45-45 field of view. So those are just mapped And then when you get the 3 points, the vertice, the 3D coordinate, you have to do like cosine sine to get the components. And then you're able to plot them. There's some kind of like memory leak because eventually it slows down, and also the Pi Pico stops sending the data too. But I tried to address that by clearing the points. You can see that here. Scene, remove, apply scene. And then I add the grid and axis helper back in. But yeah, that's all we've got right now. This plot as plain, that'll look better. It just takes a bit of time to do because you have to find like sets of 4 points that are connected to each other and create the planes and then join them together. So I'm just like out of time today, but I'll probably get that set up just because it looks cool. I've already done it before. I did it for the Twerk LiDAR robot, but anyway, yeah, so that's where we are. That's what the code is doing currently.